Hello, MSG Creator here, and in this video, I'll be talking about parity checking, parity checks. Now, what are these? Well, basically, what does a parity check do? Well, basically, it just... Okay, I need to explain this. So, first, we choose what type we're going to go with. So first we have even parity and we have odd parity. We have two parities, even and odd. Okay, now I will explain both of these. So first we need an example. So let's say we have a byte that goes something like, I don't know, 0110101. Yeah, and let's say, okay, so for a bit of context, the sender and receiver must have agreed beforehand on what type of parity they're going to use. Let's say here we chose odd parity. Okay, let's say we already had chosen odd parity beforehand. Okay, now first we'll count the number of ones, because parity checks basically depend on the number of ones there are. Okay, so we have 1, 2, 3 and 4. We have four ones. Now we need a parity bit, so the parity bit goes right here. It goes right here. So basically, since it's an odd parity, we need to make the amount of ones an odd number. So there are already 4. We need a 5th one to make an odd amount, right? So the parity bit will be literally just 1. Now let's say we had the same thing, 0110101, and we had a parity bit. And let's say this time we agreed on even parity. Now what happens? Well, again we count the number of ones we have, which is 4 again, because this is the same thing. Well, since there's already 4 and we need to have an even number of ones, we just add in 0, because that just doesn't affect it at all. Now you might have a question that, okay, it's all fine and good, but how does this help us identify an error? Well, so basically, let's take an example. We have the sender here, and then we have the receiver, and they send data to each other. This is the sender sending data to the receiver, because that's obviously what's supposed to happen. Let's say they're sending this again, and also let's say these guys agreed on odd parity. Okay, they already agreed beforehand that they will use odd parity. So now we're going with this example. Okay, so 10110101, it's already correct. But now let's say when the data was traveling nice and smoothly, an error occurred. This error caused the byte to not be this, and it turned to something like 10011. Okay, so now the receiver receives the data, obviously. Now the receiver checks the amount of ones, and they already know that it's odd parity. Okay, and it counts it 1, 2, 3, 4. Now it says, wait a minute, this is supposed to be an odd number. This is supposed to be an odd number of ones, but why are there evens? So now obviously there's supposed to be an error here. An error occurred in transmission. So well, the receiver tells the sender to send the data again, and then the sender sends the data again, and let's say no error occurred. So the receiver receives the right thing. Of course, it checks again, and obviously it will turn out right because there were no errors. But now, here comes a question: what if it was transmitted correctly? Not correctly, actually. It was transmitted, the data, this thing. Let's say an error occurred, and this error did something like this. The receiver received something like 101 01 0 0 0. So now obviously there's a problem here. Where are two of the ones gone? There's only 3 ones now. See, 1 2 3. Well, according to odd parity, it's still correct, because there's still an odd number of ones. 1 2 3. So that's one of the faults of parity check, which is that there might be a less amount of ones or a more amount of ones, but it still stays true to the parity rule, which is odd or even. Okay, now here's another thing. Here's another problem. What if the receiver, instead of receiving an error occurs and it receives something like 1 1 1 1 1 0 0. So we counted again: 1 2 3 4 5 6 7. Okay, 8. Yeah. So let's say it receives this. We still have 5 amount of ones, but they're in the wrong places. So obviously again the data has been transmitted wrong. But well, there's still an odd number of ones. So according to odd parity, this is still correct, and so is this. So yeah, there are 2 problems with this. One being that there could still be an even or odd number of ones, and 2, parity does not know if the ones are in the right places. Basically this. It still doesn't know, because they could go into whichever place they want, but it will still stay odd. So yeah, it's a pretty problematic thing, but it does sort of help with error checking, which is why a lot of machines use many other error checking methods along with parity checking. Anyway, I hope this video helped you and you take something away from it, because I really hope you guys do. And please like and subscribe this video, so it tells me that I should keep making this stuff, because I feel like no one wants this and I'm just wasting my time. Not really, it feels like it. Anyway, bye. I hope you actually understood something. This is MSG Creator signing off.